Now that we have all these tests for the equals method, let's go ahead and implement that method. And now this is another method that we're going to make a secondary method. It's not going to depend on any particular representation. And that's actually a very smart thing to do, because if you make the equals method depend on a specific representation, you're likely to mess up if you are comparing one type of implementation with another. So remember, we said that a stack with ABC in it and a capacity of 6 that's based on a list implementation should still be equal to a stack with ABC in it and a capacity of 6 that's based on an array implementation. So this is a very good method to write as a secondary method. Okay, so we're going to get rid of that. And we'll just put here return false at the end. We may have to change that. So the first thing, we're going to put a lot of if statements in here that result in just returning true or returning false. For example, right off the bat, I'm just going to check if this object is null. And if the object is null, I'm not going to throw, you don't throw an illegal argument exception, okay? Because this is a pure function, so it should be able to handle everything. So if the object is null, you just simply return false. So if object equals null, we return false. Okay, so that should pass our ABC equals null test. And now if object equals this, okay, which we're checking equality for, then we should return true. Okay, so if those are the exact same object, we return true. All right. Let me just see. The if statement is redundant. Okay, I'm not going to worry about that yet. So let's see. So the next one is if the object, let me see if this works. So if the object is not an instance of stack, okay, so for example, if the object is a string, all right, I want to return false. Okay, the stack cannot be equal to any kind of string. And if we get past here, then that means this object is an instance of stack. So one thing we can do now is we can cast this, or I'm sorry, cast this to a stack. Okay, since if we made it past here, we know that it's an instance of a stack. So here, I'm going to say stack that equals stack object casted to a stack. Now, you got to be careful here, because this is the one place you see this warning, found a raw type. This is the one place where we're not really going to worry about raw types. We are going to treat this as a stack of objects that we don't know what the type is. We could do this a little bit differently. We could, pop an object from the stack. But let me show you how this works. The limitation is here because we've got to treat everything as an object to begin with. So we've got to go ahead and cast this. And what we're going to do, now that we know that these are both stacks, okay, we don't know that the elements of the stack are of the same type. Okay, so we have to be a little bit careful here. But one thing, even if the elements, regardless of whether or not the elements are the same type, we can still check the capacities of these things. So I'm going to go ahead and just do if this dot capacity, which returns an integer, is not equal to that dot capacity, and that's kind of why I named this that, so I can do this and that. It just makes everything clear to me. I'm going to return false. Okay, so if the capacities are equal, I'm going to say forget it. And now I could do if the depths are not equal. I will do that. If the depths are not equal, I'll return false. If this depth is not equal to that depth, this may be redundant here, so I may remove this at some point. But just for my own sanity, I'm going to put that in right now. And now I can start comparing individual objects. And to do that, I'm going to create iterators for both this stack and that stack. Okay, so iterator E, I'm going to call this iterator equals this iterator, and iterator, I'm not going to put an E for this one because I don't know what the type this is. And actually, I think it's good practice to do this when you don't know the type. So I'm gonna do that throughout. So I get rid of that warning that that's a raw type. I know there's some type in there, I just don't know what that is. So that iterator. Okay, and now I'm going to iterate through this stack, but I'm going to make sure that I update that stack. Now, I know the stacks have the same depth, so the iterator, so this should work out with only calling one iterator. So I'm going to do while this iterator has next. All right, and when I'm comparing two stack, I can't use the for each loop. I have to use the iterator. You could try it with a for each and figure out why it doesn't work. But in this case, you typically have to use an iterator. So I'm going to say E element equals this iterator next. And I'm going to say, should I just say object equals that iterator next? It's a little bit tricky here. I think this is going to work. So now I've got an element from this iterator and an object from this iterator. And now I'm going to check if those elements are equal. All right, so I'm going to check if element equals object O. So not this object here, this object here. And actually, if it doesn't, I want to return false. Okay, so I just want to give up and return false. If the nth element is not equal to the nth object, if the nth element in this is not equal to the nth element in that, I just want to stop and return false. And if I get through this entire iterator, that means that I want to return true. All right, so don't get upset if you have to do an equals method and you can't get it right the first time. But I'm looking at this and I'm crossing my fingers that this is correct. Run my tests, and all of them pass.